Okay, let's look at 2D and 3D problems. So we're given a diagram here and we're given some notes. Let's go through those notes. Angle ABC is equal to X. So angle ABC is this one. There's X here. Angle ABD is equal to Y. So ABD is this entire thing, Y. Angle ADB is equal to Z, the one down here. And BD is equal to M. So side BD here is equal to the letter M. Points B, C, and D are in the same horizontal plane. So show that AC can be represented as AC is equal to M sine X sine Z all over sine of Y plus Z. So let's do that. So let's start. I see a sine X there, and I can see that I have an angle X which is in a 90-degree triangle here. It's always easier to work with 90-degree triangles, so let's do that first. So in triangle ABC, which is this triangle on the top here, in triangle ABC, I will try to find sine X only because I have sine X here in the question. So sine X is equal to opposite over hypotenuse, which is AC over AB. There we go. So if I cross multiply there, I'm going to end up with AC is equal to AB sine X. And this I will call equation 1. Okay, let's go on. In the second triangle now, in triangle ABD, I'm choosing triangle ABD because there's a lot of information in triangle ABD, and also side AB links my first equation to what I'm doing now. So in triangle ABD, I can see that it's not a 90-degree triangle, so I can only use the sine rule or the cosine rule. I can't use SOHCAHTOA. So I'm going to look at whether I can use a sine rule here. Remember, for the sine rule, you need an opposite side and angle, a pair. So if I look at side AB, the opposite, I don't have side AB, so I can't really use that. If I look at side AD, I don't have anything for AD, but if I look at side BD, I can use side BD because I have a value, and that's M. Now the angle opposite BD is A here. The problem is I don't have any value yet for A, but if I look at the triangle ABD once more, I can see that I have an angle for B, which is Y, and I have an angle for D, which is Z. Now because all three angles in a triangle add up to 180 degrees, I can work out A. And A works out to be this, 180 degrees minus Y plus Z. That's in triangle ABD. So I'm going to use the sine rule, and I'll use AB over sine of Z is equal to BD over sine of A, where A is 180 minus Y plus Z. Okay, so I'm going to cross multiply here. Actually, let's just simplify first. This bottom, the denominator of the second fraction, let's simplify that. 180 minus is the second quadrant, so we're using reduction formula here to simplify the denominator. 180 minus is in the second quadrant, and I know that sine is positive. So that entire thing would simplify to positive sine of Y plus Z. Now I can cross multiply and make AB subject of the formula. So when I do that, I will end up with AB is equal to M times sine Z all over sine of Y plus Z. And this I will call equation 2 now. Next, I will substitute equation 2 into equation 1, which means wherever I see AB in equation 1, I will not write AB anymore. I will write this. I will write M sine Z over sine Y plus Z, because that is AB. So into equation 1, I'm replacing the AB here with my equation 2 here. M sine Z over sine of Y plus Z. So AC is equal to then M sine Z over sine of Y plus Z times sine X. and that sine x here is over 1. So if I put those two fractions together, that's top times top over bottom times bottom, and I should end up with what I want, and that is m sine x times sine z all over sine of y plus z, and that's equal to AC. Next, let's find the value of AC if m is equal to 100 units, and x is equal to 90 minus y, and z is equal to y. So all we do here is we just substitute into our AC equation. So AC is equal to 100 instead of m in times sine of 90 minus y times sine y all over sine of y plus y. That simplifies to AC is equal to 100 cos y times sine y all over sine of 2y. And I can see that sine of 2y is a double angle that changes to 2 sine y cos y. My sine y's can cancel off, my cos y's can cancel off, and I'm left with 100 over 2, which is 50 units, and that is the answer for AC.